All right, so this is section 1.4, and this is a big section, so it's going to be a long lesson. We take most of the class here probably, but I want you to make sure, I want you to understand this stuff. A lot of the basic knowledge here is stuff that you know, like the concept of area. That's what we're talking about. We're talking about surface area. So the surface is something that's exposed in some kind of figure, right? So if we have, like, you know, this bell right here, okay, the surface area, I could calculate the surface area of this rounded part. It's the area that's kind of exposed to the air. Okay, does that make sense? The surface area. So it's not how much space that this object takes up, that's volume, right? So surface area would be the area that it takes up. If I had this little sticky note pad, the area of the surface, the top surface, it's a rectangle. So we would go length times width, and that would give us the area, right? If we had something that's triangular, which I don't just on me right now, but if we had a triangle, right? Who remembers how to find the area of a triangle? Does anyone know what that formula is? Do you remember that? Okay, yeah, go ahead.
Base times height.
Right, so it's very good. It's the base, so whatever the base is, times the height divided by 2. Or 1/2 base times height. That's also the way I'll write it sometimes. Okay, very good. So if you know that those concepts, we're going to put this all together. And when we talk about right pyramids, we're going to learn what a pyramid is if you don't know what that is. What a cone is, you probably all know what a cone is. But there's some special formulas in finding area of certain parts of these figures. And again, if we have a three-dimensional figure like this, let's see, this CD case, which I know none of you know what CDs are. CDs are like these ancient, okay, ways of like storing music. Okay, this is called a CD. It's called a compact disc. I know it's a history lesson now too. But anyways, if I take the CD case, it has a length, it has a width, and it has a little height. All right, so now I could find the volume of that pretty easily by multiplying simply the length times the width times the height. Or I could find the surface area, and that's basically finding the areas of each separate surface. So the top, big top part, the little side part, this little side part, this little side part, this one, and the bottom, and adding them all together. So that's what this section's about. We're going to take the individual areas of all the surface parts and then add them all together to get the surface area of the whole thing. Okay? All right. Let's take a look. What is a right pyramid? Okay, there's two parts to this term. First of all, right. You'll see that, and if you don't know what right means, think about a right angle. Okay? So a right angle is 90 degrees. Okay, so that's like a vertical line and then a horizontal line. That's a 90 degrees. Sometimes you'll see with a little box in the corner. And when you have a little box in the corner of an angle like that, that means it's exactly 90 degrees. If you see something like this on a diagram, you'll see something like this where it's rounded like that. That means it's not necessarily right. It could be 89.9 or something like that. You don't really know. But if it's got a little square there, that means it's a right angle. And it's exactly 90 degrees when we measure it with a protractor. So 90 degrees, exactly. Okay, so right pyramid, okay? So I'll explain how the 90 degrees fits in here. A pyramid, we all know about the pyramids in Egypt, right? Pyramids in Egypt. So, so the pyramids in Egypt have a base, okay? Like they have like a square base, most of them, pretty much square. And then they have triangular sides that meet up at the top, just like this picture, okay? So let's talk about some parts of this pyramid. This is a pyramid. It has a base and it has triangular sides, and it always comes to a point at the top. That's what a pyramid looks like. Now the base could be different shapes, which we'll talk about those a little bit later, but a pyramid, this one looks like a square base. So the very top part is called the apex. And if you want to write this into your notes, this diagram in your notes, that's a good idea. You don't have to write every exact word and everything that I have on my screen here, but you should be kind of making your notes by deciding what's important. Sometimes I'll tell you what's important to write down. But as we move through this, I want you guys to practice taking notes, which means, hey, that's something important. I think I need to remember that. I'll write that down. Or, hey, this is a diagram that I should memorize, so I'm going to draw that. So this is the apex. Now the height of the pyramid goes from the apex down to the center of the base. That's what the height of the pyramid is, okay? So it's from the very bottom to the very tippy top, the point top. That's what the height is, okay? The overall height of the pyramid. There's a different kind of height we're going to talk about soon, but this is a height. Now the base is the entire bottom part here that it would sit on, okay? And it's opposite of the apex, right? So the base is opposite of the point. This is not the base. This is not the base right here. This triangle, not the base, because it's not opposite of the point. Now in a pyramid, they all have triangular faces. So the 4 faces on this pyramid are all triangles. And no matter what shape the base is, except for a circle, which we'll talk about that later, but if you have a rectangle or another triangle or a octagon or a pentagon, whatever the base is, you're always going to have triangular sides. Okay? Now the other type of shape that you should know about is a prism. You guys heard that before, the prism? A prism is kind of like a pyramid, but it's got an identical base and top. Okay? That's what a prism is. So the bottom and the top are the same. That's a prism. And a pyramid is different in that all of these, the top is just a point. So if you're drawing a pyramid, you want to know how to draw a pyramid, this is what I would suggest. Draw like a slanted, rectangle or square, kind of like a rhombus is what this is called, a square that's been pushed over is a rhombus. So if you draw something like this on a little bit of an angle, and then from the middle, go straight up the page and put another point up here, that would be your apex, and then draw straight lines to each corner. Now this is tough for me to do freehand on this tablet, but that's an easy way to draw a pyramid. You start with the base, and then from the middle of the base, go right up, put a point, and then draw lines to all of the corners of the base. Okay? All right, any questions so far on this? Okay, so if I mention the apex, you know what I'm talking about. If I mention the base, you know what I'm talking about. Excellent. Okay, I mentioned that there was a different kind of height that we're going to have to talk about. And that different kind of height is called the slant height. Now notice that the overall height, I'll draw it on this diagram, I'll draw it in blue. The overall height was from the apex to the center of the base. That's the height. The slant height is from the apex, okay, from the very tippy top point, down along sort of the middle of the triangle to the side edge. That's the slant height. And of course, if we're trying to find the area of all of the faces of a pyramid, we need to know the slant height. The height that kind of like hangs down into the middle of this figure, that doesn't help us much when we're finding area. That will help us when we're finding volume soon, but not area. We need the slant height. Okay? So here is a triangular base pyramid. That's called a tetrahedron. A square base is a square pyramid. And a pentagon as a base is a pentagonal pyramid. Now the right part means this, okay? Let's get back to the right. What does right mean? Remember, right is 90 degrees, okay? So when I drop a height down like this, when I drop the height down from the apex to the center of the base, guess what? From any point here to any edge or corner, you are going to have a 90-degree angle. That's what makes it a right pyramid, okay? So this is going to be a 90-degree angle here when this height is dropped down to the face. This would be an example of a non-right pyramid, okay? This is still a pyramid, but if I put the point not above the center but way over here, okay? And so that we have these kind of like angles like this, from the apex to the center, now to any of the edges or to the middle of the edge there, whatever, or to any of the corners, that is not 90 degrees anymore. See, if that's not 90 degrees, this is a non-right pyramid, okay? So the height and the base make a 90-degree angle always, the height and the base. It's not tipped over like this. Understand? Good? Good. So I'm trying to stack all of this information. It's up to you guys to put it in your memory, okay? So how you do that, and again, this is just a little lesson on taking notes and working well in math class. Everyone learns a bit differently. Some have to draw all the diagrams, some write out explanations, okay? Sometimes, diagrams or some combination of both. Some of you really remember well by writing things down. Some of you really remember well by studying and memorizing pictures, okay? I want you to take notes and write down and write the diagrams and do stuff like that. Translate that into your notebook, because everyone, to some degree, it helps you memorize things that you actually create. Like, you can remember things that you create and see. That's a strong way of memorizing, of remembering things. So I don't want you just to kind of sit and just watch, because sometimes you get distracted, and I see some of you doze off. So I do want you to be active in taking notes. How many notes you take and how involved your notes are is kind of a little bit up to you, okay? But somehow we need to get this stuff into your brain, so that's what I'm trying to work on. Okay. Okay, let's talk about net diagrams, okay? Net diagrams. Do you guys remember hearing about net diagrams before? Okay, some of you are like, ooh, shudder when you hear of net diagrams. Net diagrams are necessary for us to at least visualize what surface area is all about. And so I'm going to get you guys to draw net diagrams for a little while here. And a net diagram assists us in determining area of three-dimensional shapes. So what is a net diagram? Well, a net diagram would basically be a two-dimensional representation of all of the sides of a three-dimensional figure. And what I mean by that is this: if you had a box, okay, here's a three-dimensional box, right? Now it does not have a top on, but I'm going to sacrifice this little box here. And if I were to cut this box along the edges, some of these edges, I'm going to try this here, pretty thick. Okay, I'm going to cut this box up, here, 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 and here. And again, it doesn't have a top, which most things will have a top as well. But if I were to fan out the sides like this, and now it's two-dimensional, right? Not three-dimensional anymore, it's kind of like just two-dimensional. So that would be like a net diagram of this box. It's an open-top box. This is what the net diagram would look like, and maybe it helps you to look at it this way. Okay? And if it had a top on it, guess what? The top would be connected to one of these sides, and I would flip open the top, and it would be like connected to one of these sides maybe, or connected to the end or something. Now, for a pyramid, we basically, it's kind of like we start at the tip here and we cut down along the edges here, and then we just flatten it out. It's like flattening a pyramid box. And what we see here is we see that we have 4 triangles that are identical, and we have 1 square base. And so in order to find the area of a figure, a three-dimensional figure, I have to add up all the areas of all the faces. Okay, so a bottom and then 4 sides. We good with that? Right? The next step then is to determine what shape the sides are and to find the individual areas. So let's take a look at this one together. A net diagram helps me understand that I have a base, and that base right here, I'll do this in black, the base is going to be length times width, which in this diagram, I'll zoom in, and you may know this, you may not, because this is said to be 8 centimeters, and all of the other sides have this single little tick mark, that means they're all the same. If they had more, like different numbers of tick marks like this, that means they would be different, okay? But if they have the same number of tick marks, that means they're all the same length. So this is 8, this is also 8 centimeters, this is also 8, and this is also 8. Everyone understand that? Okay? So the area of the base is simply going to be length times width, which is going to be 8 times 8, right? So the base here, it's a square, so it's length times width. The base is going to be 8 times 8. So the area of the base is going to be 64. What's my units?
Centimeters squared.
Centimeters squared. Thank you. The units, if you're finding area, is always squared with an exponent of 2 on the top. Okay? It's not just centimeters. Okay? The area is centimeters squared. It's the unit squared. Awesome. Okay, so that's the base we've got taken care of. Let's tackle the triangles now, and all of these triangles are the same, and if I look carefully, each triangle has a height, a slant height here. There's a slant height, see? Slant height on this diagram. This is a height of 10. So the area of the triangle, I'll use capital T for that. It's going to be 1/2 base times height, or base times height divided by 2, same thing. So I'm going to go 1/2. The base of this is the bottom of this, which is 8, and the height is 10. Right? So the area of each triangle is going to be, what's 1/2 times 8? That's 4, times 10 is 40. And that's going to be centimeters squared as well. So I've got the base recorded, and I've got one of the triangle areas recorded. So because I need to get all of these triangles in, guess what? I'm going to do 4 times the area of one of the triangles. And so 4 times T is going to be 4 times 40. So all the triangles, well, I'll do 4T. 4 triangles are going to be 160. Does that look right? Centimeters squared? Okay. So now I've got all of this area figured out, and I've got everything shaded and everything accounted for. Now the area total is the last step you have to do, and I usually abbreviate area total with A sub T, A with a T on the subscript. So area total now is going to be the area of the base plus 4 times the area of one of the triangles, or 64 plus 160. Area of this whole thing, the total is 224 centimeters squared. Does everyone agree with that? Does it look good? Okay. Any questions on that one? I'll just pause for a moment here. If you have any questions, let me know. Now, I've shown every step of work here, okay, which is great. Once you get writing and showing your work, it doesn't take all that long, and it helps your brain to make sure that it keeps checking for mistakes. So the more you try and do in your head, the more mistakes you'll probably make. So I would encourage you to show your work. I require you to show your work. This is like a lot of work. This is all the work. Okay, you can do it just like this, or you can abbreviate this a little bit. There's some steps you didn't have to write this part, right? Maybe, but you should show how you get your answers so that you can double check real quick at the end and see if you made any mistakes. Okay. Let's do this one. Here's example. Let's do this one, brand new one. This is a pyramid with a triangular base, a tetrahedron, right? So tetra means 4. So all 4 sides are the same. Jean-Marie measured, then recorded the lengths of the edges and slant height of this regular tetrahedron. Oh, also, regular means that all the sides are the exact same. Regular. All sides are exactly the same. That's what regular means. What is its surface area to the nearest square centimeter? I noticed on your quiz, this was the directive. This was the instruction on your quiz. So at the end, I want you to round it to the nearest whole number. Okay? So make sure you watch that. At the end, we'll just make sure we round it properly. Okay, so my net diagram, I'm going to draw a net diagram here. I'm going to draw a triangle, and another triangle stemming off this edge, another triangle stemming off this edge, another triangle stemming off this edge. That's my net diagram. Do you have to draw a net diagram? I want you to draw net diagrams for this section, okay? Because it might really be helpful for you, and it helps us keep track. Down the road, when you're like a mature math student, do you have to write net diagrams all the time? No. You'll be able to visualize it in your head. I think you'll be able to figure it out without a net diagram. But right now, I do want you to draw a net diagram, okay? All right. So, okay. So 9 is going to be these are 9s, right? That's the bottom edges. And then the slant height is going to be 7.8. So this, for example, whoops, that's a crooked line, but this is 7.8. So area total is going to be 4 times the triangles, right? And sometimes I abbreviate triangles. I write this little triangle shape. So 4 times the area of the triangles, whatever, 4 triangle areas, okay? So let's see what we can do here. I'm going to do 4 times, what's the area of one of these triangles? Because are they all the same? Yep, they're all the same. They're regular. So the base is 9. So 1/2 times 9 times the height, 7.8. All right, so once again, the total area is all 4 of the triangular faces. So that's why I have this 4 right here. The area of each triangular face is 1/2 base times height. And if you want to write it like this, you don't have to change your work, but some of you said you like to do base times height over 2. So you could write it just like this. That's fine too. You can do it just like that. That's okay too. You can do all this in your calculator 2 ways. You can simply go 4 times 9 times 7.8 divided by 2. You can do that all in one step. I would encourage you to see this. You don't have to do this every time, but just watch this. If I had this 1/2 here, this is a multiplication of all of these numbers. So 4 times 1/2, you can do that one first, and that equals 2, right? So you could save yourself a little time by recognizing, hey, this is actually 4 times 1/2 is just 2. So you could say, I'm just going to do, on my calculator, I'm going to do 2 times 9 times 7.8. And then if you're really quick on mental math, you would say, hey, I know what 2 times 9 is. That's 18. So I'm just, on my calculator, just going to do one little calculation, 18 times 7.8. And you can actually reduce the work for yourself by doing a little bit of mental math. And if anybody spots any mistake that I do with mental math, please ask me about it. So 140.4. Okay, 140.4 to the nearest square centimeter is 140 square centimeters. Okay, does that look correct? Any mistakes that were made there? Any questions there? Okay, so there you go. That's in your textbook, that's how they have it, and 140 square centimeters, perfect. All right, let's do a different type of question here now. This type of question is where a piece of this is not, you're not trying to find the area, you're trying to find, well, actually in this one, sorry, you are trying to find the area, but the slant height is not known. Okay, so in this question is a bit of a wrinkle. We're going to do this type next. So this says a right rectangular pyramid. Okay, so the base is a rectangle. Okay, has a base dimension of 8 feet by 10 feet and a height of 16. Whether you are a visual person or not, I am going to strongly encourage you to draw a diagram whenever possible. You might not be very good at drawing 3-dimensional shapes, but this is an opportunity for you to practice. So again, my suggestion for you, remember, is to draw the base first, kind of like a 3-dimensional, kind of like a view from above, but kind of a view from above and beside. So you're going to draw kind of like a slant like this. It's going to be slanted. And the key to drawing a good slanted sort of like base like this is make sure that the top and bottom are parallel to each other and these two sides are parallel. Make sure that they kind of like slant the same way. Don't draw them like this. Draw them parallel, okay? Now I'm gonna label this too, so the long side is gonna be 10 and the shorter side is gonna be 8, like that, okay? And we know it's feet. I won't draw feet on there because this is gonna get pretty busy. It's a right pyramid, so I'm gonna go from kind of my imaginary center here all the way up, and it doesn't really matter how far. I kind of want to make it a little bit to scale. So 16 is double 8, and 16 is bigger than 10, so I'm going to go up a little bit higher than the length of the side, up to there. Oops, up to there, okay? Now I'm going to draw lines from the apex to each corner. And that's an easy way. And just draw your lines as straight as you possibly can. You don't have to use a ruler. It takes too much time. But just draw kind of straight lines as much as you can. And there's your pyramid. Now, the height of 16 is not a slant height. So the height of 16 is actually, I'll just highlight this in blue maybe. So this is 16. Does everyone see that? Okay. Okay, so that's the information that's given in the question in diagram form. Thumbs up, good, yeah, good to go. All right, so remember, if I'm gonna draw my net diagram real quick. Okay, so here's my, whoops, on net diagram, you don't have to slant the sides. Okay, so here's my rectangular base, and I'm going to have a triangle out here and a triangle over here. These are going to be identical. Those ones are going to be the same. The ones on top and bottom are not going to be the same. Okay, they're not going to be the same. So I have to be careful with this one. There's a number of steps we have to do for this one. This is not an easy one. But what I do notice is that I do not have my slant height here. I need this height and this height. And right now I do not have that. I have to determine that. I have to calculate that first. There's two missing pieces here. Okay. So this height is going to be helpful because the first slant height I'm going to find is this one. The one that goes down to the middle of the 8. So that's this one right here. You see that? I'm going to calculate that, and how do I find that out? Well, if I zoom in here, yes, I heard it. You are going to notice that this is, because it's a right pyramid, this is a right angle down here. Oh, what? That's a right angle. And because you have a right triangle, you can use Pythagoras' theorem, or the Pythagorean theorem, however you want to say that. Okay? So I'm going to find the slant height. I know the height there, and I'm going to redraw the triangle over here. Okay, so the slant height. Okay. This little triangle is going to be 16 high. Now, what is this side? I don't know if I know this side. Do I know what this side is going to be? From here out to this edge? It is 5 because it's exactly half of this long side of 10. So you're absolutely right. This is 5. Very good. And this is going to be my S, my slant height. S. S. Okay. So this is the little wrinkle, or the tricky part of this one. You have to kind of do some side calculations first in order to get the information that you need. All right. Whoa. Let's go back to... My computer is kind of lagging just a little bit here. It doesn't like math as much as I do, I guess. It's resisting me. Okay, so Pythagoras' theorem. Okay, this means that I need to take these two sides right here, the legs of the right triangle, I need to square them and add them. So we're going to do this. And that, according to Pythagoras, has to equal the square of the hypotenuse. This is called the hypotenuse. Remember that term? Kind of, yeah. Okay. So you guys would have worked with this in grade 9 for sure, so. Okay, look at so far. So what's the square of 16? Anyone know that one? 256 is correct. 256. What's the square of 5? 25. And if you have to use your calculator for these, don't be ashamed. This is going to be s squared though. I don't know what this is. So 256 plus 25 is going to be what? 281. 281 equals s squared. Now, how do I find out what s is here? How do I get s? I need to isolate s, right? I need to get s all by itself. So any suggestions? Yeah.
Square is 281.
Right. I have to get rid of this square. So the opposite of squaring is taking the square root. The square root is the opposite of squaring. So let's, and you'll have to do this on your calculator, that's fine. So find your square root button. It's here for me, it's second function for me. You guys might not have a square root symbol. What are the different options? You guys might have like a 1 over y or something, or a 1 over x function, something like that. I don't know, you might have x square root. You might have that on your calculator. See if you can figure out where yours is. If you need help, I'll help you later. But I'm going to put in 281 in there now. And this is going to be a decimal, okay? 16.76. So I'm going to, let's do one decimal place here, okay? I always like 2, but let's just do 1. 16, oh shoot, what was it, 0.8 then? 16.8, okay. So S is going to be 16.8. That's my slant. That's my calculated slant height. All right, that's step number 1. That's really important. Now, there is going to be another slant height that I don't know, and guess what? This one's going to be a little bit different. So this is 16.8 for this slant height, and this is also 16.8. But this one is going to be a little different because I have different numbers here. So let's calculate the second one, and this one might be a little harder to see on my diagram. But what I need to do is I need to calculate this slant height on this side now, which means I have a right triangle inside there, but this right triangle now, I'll do it in red. It's going to be 16. What's going to be the base here? 4, right? Because it's half of 8. So this is going to be 4. And I'll do the same thing, Pythagoras defined S. So I'll make this one S1, and then this one will be S2, okay? Okay, so let's do Pythagoras there. All right, so once we do Pythagoras there, we get a second slant height of 16.5. So very close, but not quite the same. So those two are 16.5. All right. Okay, so again, this is a long question, isn't it? All right, now I'm going to erase all this so I have room to kind of do the rest of my work here. Okay. And in math in high school, you might take a whole page for a question. It's possible. It's going to happen. So don't worry about using paper. You got paper to use, you should use it. Make sure you show your work. Don't cheat on the space and make it so small that you can't even read it and write sideways, and don't do that. Take your time, take your space, make sure you do it right. Okay, so I'm going to find the area of the base, okay, is going to be 8 times 10. That one's going to be easy. That's 80. Okay, and we'll do our units later. Now the area of, let's say triangles 1 and 2 are going to be this one. So there's 1 and 2. Okay, so I'm going to have 2 times the area of this triangle is going to be 1/2 the base, so that's 8 times the height of 16.8. Does that look good? 2 times 1/2 is just 1. So that's going to be 8 times 16.8. 8 times 16.8. 134.4. So 134.4, that takes care of these 2 triangles, right? I have the base taken care of. I've got those 2 triangles. I'm going to use a different color here. I'll use, let's see, red. So these triangles here are going to be the next triangles. And yeah, sorry, AT is usually I say total, isn't it? But let's say that, you know what? I'm going to use my triangle designation, my little diagram. So the area of these triangles here, and you guys can do whatever you want. I'm going to use that. So these red triangles are going to be, I've got 2 of them, and each of them are 1/2 times the base of 10 times the height that I calculated earlier was 16.5. So that's going to be, that's 2 times 1/2 is just 1. 10 times 16.5, I don't even need my calculator for that. That's 165. Right? Like 0.0, it's even. Okay. Okay, how is it looking so far here? Are we looking okay so far?
Yeah.
Okay. This can be a long question, I know, but don't be afraid of long questions, okay? Usually in your homework, you don't get as many long questions to do because they take longer. So embrace the process. All right, so what I'm going to do now is I'm going to add up this area plus this area of these 2 triangles plus this area of the other 2 triangles. And my area total, I'm going to write actually total there, is going to be 80 plus 134.4 plus 165. Did anybody do that already on your calculator?
379.4.
Oh, sorry, say that again, can you hear it?
379.4.
379.4? Okay, is that confirmed by anybody else that did that on the calculator? Usually I like to have 2 or 3 confirming the same number. That's great. Okay, so what's the unit there? It's going to be square feet, right? Or feet squared. So you don't need to write a sentence for these words or problems. I'm okay without writing a sentence. Just make sure you have your units and rounded prop. Oh, this says to the nearest foot. Okay, sorry. So we're not done yet. Nearest foot here. The area total is going to be, this 4 is less than 5, so we'll keep it at 379. 379 square feet, or feet squared. All right, now that might be slightly different than the textbook's answer that they might show you in there because we might have rounded just slightly differently. Again, 1 decimal place is okay. If you're unsure, take it everything to 2 decimal places if you're unsure. But okay, how about that? We good? 2 thumbs up? 5 out of 5? Any questions?
This video will be posted, right?
Yes. Yeah, you'll be able to watch this video online here soon. Okay, I'm going to keep moving on because I've got about 10, 12, 15 minutes here. I don't know what I have, something like that. This is a long lesson, so I'm going to take most of the day today to teach, probably all the day. And then tomorrow, I'm going to give you time to work on your homework and practice the stuff, okay? So there's not going to be homework time in class today. So let's keep going. All right. This one I won't take too much time on because it's very similar to what we've already talked about, but in the textbook you'll see that they have a page dedicated to this. So surface area of a right pyramid with a regular base, we've already done that. The one tricky part about this is finding the area of the base, okay? This is not a triangle or a rectangle or a square, which is easy to find the area. In something like this, what you're gonna have to do, and again, tomorrow we'll work on this, in a net diagram, this is how many? 1, 2, 3, 4, 5, 6. So this is a hexagon, this one. So 1, 2, 3, 4, 5, and 6. Each side is going to have a triangle coming up from it, right? So the net diagram is going to look like this. This is where net diagrams start to become pretty helpful, okay? Kind of a neat shape, a little bit of a star, I guess, there, a little bit, if I do that correctly. But here's the tricky part about this one. Again, this is going to take a little bit more time because this area of the base, there's no just one quick formula for that. Instead, what you have to do, and I'll zoom in just a bit, what you're going to have to do to find the area of this base is you're going to have to split this up into a number of triangles. Now, all these triangles are going to be the same, so there's going to be 6 triangles here, but you have to find the area of this one triangle and then multiply by 6 to get the area of the base. Okay, let me say that one more time. If you have a figure like this, you're going to have to break this down into smaller problems, and you're going to have to find out the area of one of these triangles, like this one right here. Find the area of that one, and then multiply by 6 to get the area of the base. Then you're going to have to find the area of this triangle and multiply by 6 to find the area of the lateral sides. Add them all together, and then you're done. So there's one little wrinkle when the base is not a triangle or a rectangle or a square. Questions? Tomorrow, maybe, tomorrow I might do an example like that, okay? I might do one tomorrow, but I probably won't do one today. Okay, view, let's go back to 100%. Okay, I think the last thing I need to talk to you about today is what a cone is. You've all had an ice cream cone in your hand. Now, some ice cream cones are shaped differently, right? Some ice cream cones kind of look like this. If you're like old school like me, this is the only ice cream cone that you're like aware of. But it kind of has this little cylindrical handle here with another cylinder kind of popped on top. And then you have your ice cream, right, mounded up here, right? So there's that kind of cone. This is not the cone we're talking about. We're talking about this cone right here, like a waffle cone or something, where it's like comes to a point, right? And you have your ice cream here. So this shape of what the ice cream sits in, that's a cone. You turn it upside down, it looks like this. So this is still the apex, this is still the slant height, but there's no sides. Because when you have a circular base, it's like a circular pyramid. It's a pyramid with a circle base. You don't have any sides. You have an area of a circle on the bottom, okay? And really this is a right circular pyramid, also called a cone, a right cone. So what's the difference between finding areas of regular pyramids and cones? Well, the tricky part is, and I will show you the net diagram of this guy. So the net diagram consists of a circle. That's terrible. A circle. That's slightly better. And then the wraparound part. Now this is tricky to draw. This wraparound part is not a triangle. It's close. but it's not a triangle. If you were to cut this and lay it out on the ground, and many of you, have you had a, what's that called? Yes, no, but it comes wrapped. It's like a, what are those? Drumstick, yeah. If you had a drumstick and you take off the wrapper looks like this. It's rounded here, isn't it? It's rounded there. So it's kind of like a triangle, but it's more like, this looks like a lamp now. But you have a rounded piece. Let me just draw that again. So this is rounded. So that means that we need to have a special formula for the area of this part. Okay, because that's what you would get when you split that cone up and made a net diagram. So I'm not gonna like show you kind of how this is calculated. I'm just gonna give it to you, okay? But the area of the lateral area, that's the wraparound part of the cone, is pi, and that's like that 3.14159 number, right? Which is a special constant for circles. Pi times r, the radius of the circle down at the base, times s, the slant height. So pi rs, that is going to be the area of this part right here. Pi rs, that's the area there, okay? And then the base area is pi r squared. So this is pi r squared. Okay? So let me just, so I can copy this here. Yeah, let's shrink that and bring it down here so it's all on the same screen. Okay? Have you seen this before? Or is this brand new? Some of you maybe have. Okay, so the surface area is two pieces, pi rs, which is the wraparound area part, and pi r squared, which is the circle part. Okay. Let's do example 3 here. A right cone has a base radius. And if you like to draw, this is how you draw cones. Do like half a circle, then pick a point above the middle and draw a straight line to each edge. And then if you want to draw the backside of the base of the cone that you can't really see in a three-dimensional figure, then you kind of finish the other half of the rounded piece of the circle, make a dotted line. That means that it's back there, but you can't really see it from the front. All right? So the radius is the length from the middle to the outside, so this is 2. And the height of the cone is 7 feet. There's this part. 7. Calculate the surface area of the cone to the nearest foot. Now, what's great about cones is, you know what? The slant height and the height and the radius, they all still make a regular right triangle, so that's awesome. So we need to do the exact same thing that we did with the last example. And I know this is a lot of information today. I apologize. You guys are getting slammed with like excess of information. I get it. You guys are doing great though. This will take time to work through, so be patient with yourself. But I do need to find the slant height here, and we're going to use Pythagoras again. So this is going to be 7, this is going to be 2, and I'm going to find s. So 7 squared plus 2 squared equals the slant height, s squared. That's going to be 49 plus 4 equals s squared. That's going to be 53 equals s squared. So s is going to be the square root of 53. Did I do that right? 49, 53. So the square root of 53 is 7.3 feet. And so the nice part about this is, even though it looks a little confusing, the surface area formula makes it really nice for us. It's really easy to find this surface area now that I have s and r. I'm good. So pi rs. Now, I don't want you just to use 3.14 as pi anymore. You all have scientific calculators. I want you to use your pi button on your calculator. If you find yourself without a scientific calculator, the minimum number of decimal places you have to use here to get a right answer is 3.14159. Okay? But on your calculator, everybody with a scientific calculator should have a pi button. So pi times r, which is 2, times s, which is 7.3, plus pi times r, which is 2, that's squared. So, let's see. Pi times 2 times 7.3. My pi button is right here. It's a second function. Use that button, please. Times 2 times 7.3. So I'm going to do this one piece at a time. So 45.867. I'll use 867. I'll use a few decimal places, as you know, more than just one during the question. I'll round it at the end. And then pi times 2 squared, that's the same as 4 pi, isn't it? So you could do a little mental math in your head. 4 pi, 12.566. Okay, 12.566. 2 or 3 decimal places is plenty because you're going to round it to the nearest whole number later anyways. So I simply add those numbers together. That if you just hit plus after you've come with a determined a value on your calculator, if you just hit plus, your calculators will just take that answer and then recopy it for you. So you just hit plus, don't clear it, just hit plus, and then type in the other one, 45.867. And I get 58.43, so 58.43. And to the nearest square foot, the surface area here then should be 58. And the units are feet squared. Make sure you have the units. Whew. All right. How do you feel about that one? I know you're tired. I'm tired too, man. This is tough to teach. Okay. All right. I'll do this one for you tomorrow. This is very similar to other questions we've done. But here's your homework for 1 point. Shh. Okay, guys, quiet. Here's your homework for 1.4. I will give you time in class tomorrow to do this, but please write this down so that if you get some time today to start, it would be a good idea to start. It's all on the website as well, MrMathWell.com. Go to your Foundations and Pre-Calculus 10 webpage, you bet. Here's your assignment. You will get time tomorrow to work on that, but please write that down. Good job today. It was a long lesson. Hey, everybody want to yell goodbye to end off the video? Bye. Like and subscribe.